We are going to talk about conjugates now, and these are very useful when we're rationalizing denominators of more than one term that have square roots. And here's the reason why. We're going to start actually with a number, square root of 3 minus 1, and its conjugate, square root of 3 plus 1. And I'll give a more concrete definition of why these are conjugates in a minute, but I want you to notice what happens when we multiply these out. Notice that this is a difference of squares. Square root of 3 is the same as square root of 3. 1 is the same as 1. So what we get is this first one squared minus the second one squared, which is 3 minus 1, which is 2. So we got a single number out of this when we multiplied the difference of squares. In fact, these are called conjugates of each other. If the only difference between them is the sign in the middle of the second term, then they're conjugates, and when I multiply them, I'll always get a difference of squares, and conjugates will always clear the radical away. So, let's talk about how we find conjugates. Suppose for a minute that I have 2 minus the square root of 3. This is given. Well, my conjugate is just the difference of squares. All I have to do is take the same numbers, grab that sign in the middle, and change it, and I've got my conjugate. Now notice I'm always changing the sign of the second one. So if I have minus the square root of 7 plus the square root of 5, my conjugate is going to be minus the square root of 7 minus the square root of 5. I only ever change that sign. Leave this one alone. And if you do that, you'll always get your conjugate right. Well, let's look at one more just to demonstrate. Square root of 12 minus 3. The conjugate is the square root of 12. A 3, and the minus becomes a plus. And that's how we find the conjugates of radicals.